Hey Math Kids, today we're going to talk about how to use the discriminant to tell us some properties about a quadratic function. And so the first thing we need to do is talk about what a discriminant is. Now delta is the symbol for discriminant, and the discriminant is this portion of the quadratic formula. So if you remember from the quadratic formula, I'll just write it out. It's just the portion that is underneath the square root. So just this portion is called the discriminant, and it can tell us a few things about the nature of the roots of our quadratic. And so if we have a discriminant, like if we plug in numbers right here and simplify, and we end up getting a positive number, or a discriminant that is greater than 0, then we know that it will cross the x-axis 2 times. So what it's going to do is it's going to create a situation like this, where we cross here and here. Now, if we have a discriminant that is equal to 0, it's going to touch the x-axis. And so that's going to be a situation like this, where it just dips down, touches right there. Now it still creates 2 roots, because right here it's obvious there's 2 roots. This is 2 roots, but they'll just be the same thing. So for example, if this was -2, the roots would be -2 and -2. Over here it might be 2 and -4 or something like that on the pink graph. Okay, the other scenario is that the discriminant is negative, and this will not touch, won't touch x-axis. So that's a situation like this. Maybe it's upside down and just doesn't touch. Now once again, it still has 2 roots. They'll just be in the form of like 3 plus 2i, 3 minus 2i. Or if you were doing the quadratic formula, you'd probably end with an answer that looks like 3 plus or minus 2i. So it still has 2 roots. All quadratics are going to have 2 roots. But on the pink graph, we say that it has 2 distinct real roots. On the green graph, we say it has 2 repeated roots. And then on the yellow graph, we say it's 2 complex roots. Okay, let's do some examples so you can see like how your how it's going to show up on your homework or on a test or something like that. So we want to use the discriminant to determine the relationship between the graph of each function and the x-axis. So basically we're just going to say, does it cross 1 time, 2 times, or no times? Okay, so we're going to use the discriminant, and remember that's b squared minus 4ac. We are going to plug in, so once again it's a, b, c. So our b is 3, so we get 3 squared minus 4. A is 1, ninja 1, that's right there. And then c is 4. So we're going to get 9 minus 16. Now, that's a negative number. That's all we care about. We don't care specifically what the negative number is. But since it's negative, we're going to say does not cross x-axis. Now, since this is the leading coefficient is positive, we know that it's a parabola that looks like this. And so it would be a situation like this, where we have the x-axis, right side up parabola, but it does not cross. Okay, there's a part B on this one, and it's y equals -2x squared plus 5x plus 1. Once again, we plug into the discriminant right there. So we have our a, b, c. B squared is going to be 5 squared minus 4 times A, which is -2, times C, which is 1. Okay, so we get 25. And then -4 times -2 is going to be +8, and then times 1 is still +8. Positive plus a positive is going to give us a positive answer. Once again, we don't care what the number is, we just care for the sign. And since it's positive, we are going to cross the x-axis twice. Now this is negative leading coefficient, so it is upside down, and then the x-axis would look like that. And so we know that it's going to cross twice in a situation like that. All right, we have one more example. This one says, find the values of k for which the function y equals x squared minus 6x plus k. And so it says cuts x-axis twice, B touches x-axis, so that just means crosses once, and then C misses x-axis. Okay, so what we're going to do, we're going to plug this in. I know this is a k, but we're going to still plug it into the discriminant formula. And so I get -6 squared minus 4 times 1 times k. Now we square that, we get 36. And then this is going to be -4k. Now we need to go through all the scenarios. So to cut the x-axis twice, we need this to be positive. So we're going to say 36 minus 4k is greater than 0. And so we just go through the algebra on that. Add 4k, add 4k. 36 is greater than 4k. Divide by 4, divide by 4. And so 9 is greater than k, which actually means k is less than 9. So when k is less than 9, we get the situation where we have two real roots, or we cut the x-axis twice. Okay, now we go through the scenario where it just touches, so that's when it's equal to 0. And, you know, it's going to be related to this, but I'm just going to show you. So 36 minus 4k equals 0. Add 4k, add 4k. 36 equals 4k. Divide by 4, divide by 4. 9 equals k. Alright, we're seeing kind of a pattern, right? So k equals 9. Now I want you to take a guess what you think the missing the x-axis is. I'm still going to go through the algebra, but hopefully you're starting to notice what's going on. So 36 minus 4k is less than 0. Add 4k, add 4k. Move over here. And so we get 36 is less than 4k. Divide by 4, divide by 4. And so 9 is less than k, or k is greater than 9. And so for it to not touch, k is greater than 9. Okay, this situation will happen every time. So really, you just need to do either the cuts the x-axis twice, or misses the x-axis twice, or misses the x-axis. And then, you know, this is going to be an equal to the touches the x-axis. And if this one ends up being less than, this will be greater than. If this ends up being greater than, then this will be less than. So you do need to do one of them all the way through, and don't do the equals one, because you won't know which one's greater than, which one's less than. But you can probably save yourself some work if you notice that pattern. Okay, if you need additional help, come to office hours, which is just like math lab. But until then, calculator.